Hi there. I believe we're live now. So we're here with Sebastian Daschner. Hi, Sebastian. How are you doing?
Hello there.
How are things at your side of the world?
Things are doing pretty okay. I'm just focusing on, like programming, and as developers, we can spend the time quite well, so that's good. And yeah, we have some interesting content at this live conference. So yeah, looking forward.
Okay, excellent. So we're super excited to have you at JakartaOne Livestream 2020, and it's the Livestream second edition. And I believe today you're going to talk about testing Jakarta microservices with efficiency and joy.
Yes.
And that is a fabulous title. So um, we can, and I don't think I need to do any special introductions for Sebastian. We're all familiar with you and your fabulous work. And we know based on the logo there, who are you working for, that fabulous IBM logo. So if you want to just take it over from here, that would be great.
Well, yeah, thanks a lot for the introduction. And yeah, for everybody, welcome from my side as well. And I'm very happy to be here on the second edition of the JakartaOne live stream. I even have some pin here about the second edition and some about, yes, very excited. So Jakarta 9, like my Duke really likes these, enjoys these pins. So
Fantastic.
that's that. And yes, I'm also really happy to share some interesting content on testing microservices with efficiency and joy. And yes, there is such a thing like testing with efficiency and joy, although it sounds a little bit questionable at the beginning. And I know many developers are not that enthusiastic about testing, but I want to change that a little bit. So why not just like get right started? Because if you know me, then you probably assume correctly that I have a lot of live code and live demo for you. So I'm going to
We
just
do.
start right away with sharing my screen so you see a little bit of that. So let's get going with this. Yeah, that's the first title slide. And about myself, my name is Sebastian. I do things with Java. I work for IBM and so on and so forth. And also a fun fact about me, I like coffee. So today, what I will show you is some coffee shop example application. And it's quite important to me for this testing topic that we share something, or that I show you some examples that are actually a little bit more than, just trivial hello world, but so we actually have some microservices where there's something going on. Why? Because for the testing perspective, it's quite often the case if that you look into some material that's maybe, like Stack Overflow or whatever, that it's just a little bit too simple. And if you compare it to a real world project, you really notice the difference on which approach makes sense on a, bigger scale or for a more complex setup or not. So what I have for you is actually a coffee shop application that looks a little bit like that, where we have this application in the middle. That's going to be, of course, a Jakarta microservice. I use Quarkus to run that. And also we have some database. So even in our quite simplistic example, we at least already have some persistence that, of course, we need to deal with when testing this application later on. And the user is going to talk to that application via HTTP, for example, and order some coffee. So that's basically the scenario we would like to have some coffee. And then also, just to make it a little bit more interesting, we're going to have some asynchronous communication with that barista backend. So, the friendly person who brews your coffee. And to make it more interesting, we have an asynchronous communication. So to see, well, if we set up a more complex testing scenario, we of course need to account for that, right? We need to make sure that still everything works, also from a more complex use case perspective. And now that's what I want to show you. So here what we have is a project, or actually this one. This is the coffee shop project. And I have, well, two projects, this coffee shop and the barista. But the main application that we would like to test is this coffee shop application. And what I have, this is a Quarkus application. So probably you heard about this interesting technology that's now around for about 1.5 years. supersonic subatomic Java. That's the good news. It supports Jakarta and MicroProfile APIs. So you're probably familiar with writing some Quarkus applications here. You can check out that website, quarkus.io. And I have, well, some resources there for you. So some classes and, like JAX or REST, some REST communication. But instead of talking, I just can deploy this locally and show to you how we actually run this. And in my local setup, that's already the first interesting thing. What I would like to show you is how to test this, first of all, locally in a manual approach, just what the application does. And in order to do that, I'm going to deploy it locally. So that's already one takeaway to test something with efficiency, that I want to be able to test something in a local setup. Not all of the applications actually have to be set up in a correct way. There can be some mocks instead and things like that. So we're going to cover that. But in general, I want to be able to set up my environment just very quickly, ideally locally. Thanks to containers, I can actually do this. So what I'm going to have now, I start 3 containers locally. Why 3? Well, 1 for the coffee shop, 1 for the barista, and 1 for the database. So if I start this and I've asked Docker, it shows me 3 running containers, 1 coffee shop, 1 barista, and 1 coffee shop DB, which is actually a Postgres in my case. So I'm going to start this up. Awesome. And I have some locally published ports. So via localhost, I can just ask my application to please order some coffee. And now simultaneously, that's 8001, I will show you the Java code and at the same time just what this produces here. So /health, that's a MicroProfile health check, by the way. It shows me that my application is up and running now. So my coffee shop is there. That's good news. And I can show you, well, there is an orders resource. So ultimately, we're going to talk about coffee. So we have something like coffee orders that I actually can persist in my database and that I can communicate with using this JakartaOne resource. So I have this orders resource like /orders where I can, read some coffee and create some coffee orders by posting to some JSON and things like that. And then we can briefly walk through this code here and see, okay, actually, this is, a JakartaOne resource. And then we have some CDI injected beans. So I have a coffee shop that is actually a transactional application scoped bean. And then, I talk to my database and so on and so forth. And well, by doing so, okay, let's check this out. I can actually ask my orders endpoint to give me the list of all orders. So, and that is an empty array. So there's no order in the system. Okay, so to change that, I would like to post some JSON to the application. So I would like to create some coffee order. Okay, how is an order represented in JSON? Let's have a look at this. So there is just a class here that's a JPA entity, which also is used, which I can use to just persist it. So I have a coffee type that is something like a drink type, and an origin that is like, the country, the coffee origin from the drink that I would like to order, which I need to specify at my order. So I say I have something like, an espresso, and the origin is beautiful country, Colombia. Okay, let's do this. And now if let's do it again and ask for the headers. 201 created. Okay, great. This worked. Now, if it worked, then actually, if I ask for the orders, I should get them back, right? Okay, let's test this as well. Okay, awesome. I got now 2 orders in the system with some, origin, and they also have some status. Okay, interesting. And even I was a little bit too slow. If I make it immediately, I see that also the status gets updated. Okay, so what's this? Let's try it again. At first, it says coffee here preparing. Then it says finished. And then after a while, it says collected. So this is actually this asynchronous communication that we have with our barista backend with the other microservice, where this, ping pong communication is happening that shows us, that the coffee is actually now being produced. Okay, so, by doing so, we already tested it, right? Like manually. That's already typically one of the first things we do as developers, right? We write something and then we try it out, something like manually. We run it by a local host, we run some main method, whatever. And it is, if you argue, already now ready for production, right? So I tested it manually. I checked out that I could persist some orders. I saw that the orders in the system here. I could also test, if I shut down my application and the database key is still there, that afterwards my order is still available. I saw that the status transition works. Okay. But, well, of course, this is not the best way to test this in a somewhat efficient way. Why? Because this was a manual test, and tomorrow, if I change something in the features, I would need to test it again. So, of course, I would like to have some automated test. And what I would like to start with is a so-called system test or some sort of acceptance test, where I actually test my application, somewhat similar to, this one. System test that tests actually the application, the coffee shop, and then it uses also the barista application. It can be the actual barista like I used, or it can be some mock. So what I would like to test now is similar what I did on a command line, is to just examine whether my coffee shop microservice behaves correctly. That is using the correct deployment. It will be deployed in the same way like later on in production and using the same endpoints. That is important to have efficiency, right? We would like to test with efficiency. Why? Because if I change something in the configuration, if I run my application a little bit differently to production, then I actually need to test it again, because every difference that I have might later on just fail. So that's an important point to mention. And this is why in my system test environment and locally, I could argue this is already a system test environment. Why? Because I run Docker containers, and the containers are started from the same image that would be deployed to production. So that is something that I can already start with. But of course, instead of doing the command line, what I would like to have is to run something like a system test from Java. Why Java? Well, because I'm a Java developer, it doesn't even have to be the same technology. It doesn't even have to be Java. If you would like to write your system test from a command line, you can do that as well. But I just advise to use, technology that you're familiar with. So I have the system test project that I typically like to separate. Why? Because then not accidentally I'm reusing some sources from my production code, and then I might change one side and I forgot that I changed one side already and the test is green, although it should be red. And in this case, I like to separate them, and I have something like this here, which is called create order naive test. I'll tell you in a second why naive, but this is basically a pendant in Java to what I just did in the command line, that you see, well, we're going to connect to our system, which here is localhost, and I would like to, create some order. So I would like to HTTP post to my Jakarta application and then post something. So here, what I'm going to do, create verify order. This is this method. Okay, let's try to look through it. New order. Okay, so HTTP post, I would like to post some JSON to this resource. This is what I did in the command line. If you remember, I have this orders target. So what is this? That's a JakartaOne client API. So I use JakartaOne on the client side. I could use any HTTP client that I want, but actually, since I'm already in a Jakarta project, I typically like to reuse these APIs because I'm typically familiar with them, and so is the team. So that's usually a good idea. And then I can use this to, request this HTTP post, then check whether it's successful, and so on and so forth. And then probably you saw that I have some HTTP location header. So once I post some new coffee order, then I see where the order is actually, where the order resides. And then later on, I can get some more information like type, origin, status. So basically, I can use that to ask, okay, is the order now in the system? And it looks correct. So I just created, a espresso Colombia order, and it says, okay, espresso from Colombia. That looks good. So I assert that this is the case, and then bonus points if I list all orders and see if it's inside. Okay. Now, if I would ask you who has seen test code like this, then probably a lot of you would, say, okay, I've probably seen or written some system test like this, like just one step after another, which comes naturally if I would like to replicate what I just did in a command line. But is this a good idea? Not necessarily. Because first of all, if you look into this method, I had to now talk and walk you through, but on the first glance, you don't really understand what it's about, right? You're kind of like, okay, there's some HTTP and some status and some JSON and whatever, but it's actually a totally different question what you would like to test. And this is one of the biggest challenges that I see in test code, that there are test methods that are, well, too big, or to do too many things, or to be more precise, they have too many concerns. They are on too many abstraction layers at the same time. And what is wrong with this? Well, first of all, you don't really comprehend it at the first glance. You really have to read through it. Okay. And then second, now, question to you, what happens if tomorrow I have a new feature and I implement not only Colombia, but Ethiopia? Or somebody wrote into the chat for Brazil, like Brazilian coffee, so espresso from Brazil. Now, if we would like to do this, then of course, what's going to happen, you know what is going to happen. I take this method and I'm going to copy and paste it to here. And then I said, okay, now create verify order from a different country, or for example, for cappuccino, right? So create verify order cappuccino. Now I have a typo here. IntelliJ complains because IntelliJ knows about coffee apparently. Cappuccino, now it's correct. Cappuccino. Nice IDE that tells me that my coffee spelling is incorrect. That's great. Now I have to change this, right? And then I have, well, actually to read my method, is there another occurrence of cappuccino and so on and so forth? So, this is not really sustainable, because what's next? Well, guess what? What if I change the country as well? Then at some point I end up with many, many copy and pasted lines of code, which is just a bad idea. Okay, what is actually another problem? Well, what if we change the communication from JSON to something else, or HTTP to something else? Then you can throw away this whole class, right? Because it's just too much entangled between your actual test scenario code and the implementation. And the missing point here is the following: abstraction. So what you have in this test method, you have too many levels of abstraction at once. It does too many things. It has too many concerns. So first of all, it has the concern of the actual test scenario, then about the communication, how to talk to my backend, how the orders are represented in JSON and so on. And that's a bad idea. So what I would like to do usually, I like to start from a blank space and just ask myself, what am I going to test? So if I have some, just some pseudo test here, and if I say, well, actually, what are you going to test from a very abstract perspective, from a user's perspective? What do I want to do? Well, I want to create some coffee order with some information, right? With espresso and from Colombia. That's what I want to do. That's it. End of story, right? That's my test scenario that I would like to have. And then afterwards, I would like to, verify the coffee order. Okay, I would like to identify it somehow. So let's say I'm going to save the coffee order ID, right? And then I say verify that the coffee order so-and-so has espresso from Colombia. So I verify that the persistence is correct. And then, and so on and so forth, I can verify that the list has this coffee order, the list of all orders, but that's it. That's actually my test scenario from an abstract level, what I would like to test for the user. And now, then we can talk about how we're going to create the coffee order, how that is implemented. And if we follow this, then we actually end up with a test that looks a little bit more like this. So that's the proper create order test, where we say actually, okay, create verify order, that this is the case here. And I think for later on, not for my test to fail, I actually have to delete them again for the cappuccino. Let's do this quickly. Now, what I'm going to do instead, create verify order, that's the same method. I say new order, espresso Colombia, okay. And then coffee order system, that's a delegate here, just a plain Java class, nothing special, no magic. Dot create order. Okay. How it's going to create the order, I have no clue. And I don't want to know. I now care about my test scenario. And then coffee order system get the order, load the order by this identifier. I use a URI here. And then just make sure that's actually, that the information matches the type and the origin and so on and so forth. And that's it. And this is my test method that I would like to verify. And now if I'm going to copy and paste this code, then it's actually comprehensible because I see what information I have here. That there is just an espresso and Colombia here, just information, I see it immediately. And, and so on and so forth. And now if I'm interested, how it's going to be created, well, I look into this delegate, obviously. So I look into this lower abstraction layer, and this now encloses everything that is, regarding HTTP, regarding JSON, but not regarding my actual test scenario. So I separate these abstraction layers. And well, actually, there shouldn't be anything new for you, right? Because in production code, we do this all the time. We care about proper test code quality. But I can tell you it's not forbidden to do this in test code. It's actually a good idea to do it there as well, to just end up with maintainable tests. Why maintainable? Because now, like I told you, if something in the test scenario changes, then quite quickly I can change it here without modifying the other delegates. If I have 100 new test scenarios, that's also okay. I just create, a bunch of new methods, and then I reuse the other components, these delegates. And if something on a communication side changes, like HTTP, JSON, something else, then I only have to change it here because I made sure that I don't have any leaky abstractions. So if I talk about create order, I don't say, JSON anything or HTTP status. I don't care about HTTP status. I just see new order, and the order, that's actually a special type here just for the test scope or my test project here. It can be, it doesn't have to be strictly type or whatever. That's fine just for the test scenario. But I make sure that I don't leak anything here for the underlying details. So that's quite
Hey,
quite important.
Sebastian.
Yes.
Sorry for interruption, but there are some comments here, questions/comments. I don't understand why test-st is out of project, why it is not within the project, like JUnit IT integration test.
Yes, that's a very good question. So as you saw, this is a separate project, ST, that stands for system test, or, like some specific test project. Why is it a separate project? So here, this is also Java, and this actually uses a Java, a usual Maven Surefire test, like, TEST test. Why is it separate? Just to make sure that I don't have any accidental coupling with the code. So with my system test that I have somewhere here, it is a separate project, and it should not be entangled to the production code. So potentially you could swap it to any other technology. If you would like to write your system test in bash scripts, that's also fine. It's basically what I did on a command line. So you specifically don't want to have any coupling to your production code to basically say, well, I really want to test my system from the outside. So I only and exclusively use the external boundaries for this test. Why? Because now I want to simulate what the user is going to see. So it's the same thing as if the user really would go against my application using Curl, using some other HTTP client, and say, well, please post some, like JSON to create some coffee order. So in this case, I'm not tangled to my production code or to my code of the project. In a second, we will see some example for actual code level tests, like the more typical unit tests that do have the connection to my code, because that's also required. But for this first perspective, we really want to look at it from the outside to say, please connect to my application and see whether everything is working correctly. So I hope that that clarifies it a little bit more, but please feel free to ask more questions or type into the chat if not.
So there is one flattering comment/question. What is the family font you use?
The family font for which one? For in the I think, or actually, I think everywhere it is the IntelliJ, the JetBrains font, JetBrains Mono. So the one that ships with IntelliJ now, and I also have, yes, that's also the one I use in the command line. So if you want to check out the font, since some installation in this one, if you can read it, JetBrains Mono, the latest versions of IntelliJ ship this per default. And what I did, because I really like the font, I downloaded it and also included in my command line and in my editors and all that. So I use this font now everywhere. It's open source as far as I know. And yeah, that's a really nice one. So thanks for the question. You can check this out yourself.
Obviously, others like it as well. Yes.
Nice. That's cool. All right, so that's about this test. Now, one more thing that is a little bit more interesting now, if we also test the communication between these two microservices. Why? So we also have, some communication down here happening between the coffee shop and the barista. And well, we want to see whether this is correctly. This is correct. And well, it is not that easy in the beginning. Why? Because it's an asynchronous communication. And just because we right now created some coffee order, we don't know whether it's there immediately or just some time later. So what I have here, I have a second delegate, not here, but here, second component in my test. That is the barista system. So that also encapsulates the communication with my barista. And of course, from a user perspective, I don't have to talk to the barista, right? That's an internal backend. But now for my system test, I actually do. Why? Because I can deploy a mock service. Why should I do this? Well, in the same way, like I use mocks like Mockito on a code level to see whether this interaction is correct. So I can control and verify whether all of the communication here is done correctly. So what I can do, I use, in my case, wiremock. So instead of the proper barista in my system test environment, and I can do this locally as well, thanks to containers, I can actually deploy a wiremock that is a mocking HTTP server instead of the actual barista, and just say, well, like a mock, just act as if you were a barista, and then, respond correctly to the correct HTTP invocations. So this second communication is also HTTP based, but could be anything else. And then I say, well, if you, it's very similar to Mockito. If you will be called for this endpoint, please return so-and-so. And now I can answer for this particular order with that status, and so on and so forth. And then what I do here, that's now the second more complex method, and I will run all of these in a second. I say, well, please create my order again, and so on and so forth. And now answer for the following order in that following status. So if you will be called in the future for this order ID, then please say preparing status, and afterwards, blah, 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 say finished status, and then we test this ping pong status transition, whether all of the communication is correct. So what I have to do in the meantime, and there is basically no better way for this, because it's asynchronous, I don't know when it happens. I basically have to wait for the invocation to happen in my system test. So I say, well, in a loop somewhat, see if it already has been invoked for the specific request where it already matched. And if that is the case, then, well, continue with some timeout. So that's basically it. And then I can see if not only the information, but also the status transition is correct. So let's test this here. I'm going to start my Docker containers, and I'm going to fire up a system test environment that is very similar to what I just did. But instead of the correct barista, I run just mock, a mock server, wiremock in my case, and then I can actually talk to this mock server using my system test. So that's basically now what my system test locally does. It connects to the coffee shop to create my order, and also talks to the system test to set all of that up. Okay, once that is the case, let's check this out, whether it's being deployed for the health check. Then I can actually fire up my system test locally. So let's see. Yes, now it's up and running. That's good. And then I at first can run, well, this very test. So I can run it, of course, either via Maven from the command line or via my IDE. So this is, again, a surefire test. So I can just simply say a Maven build or a Maven verify, but now in the system test project, different project. A test in this project would then fire up the system, system test, verify order. So this already worked. Okay, if it worked, let's check it out. Orders. Okay, looks good. So now this is there. I can do it again. So I can run it again, and then the order will be there. Now, testing with efficiency and joy. You saw how quickly I could start up my test. So my point is, what I really like are environments, system test environment, where I separate the environment lifecycle from my test lifecycle. So in case you're wondering why this is just a plain JUnit test, nothing fancy, no, like run with annotation or a test extension that fires up a lot of stuff. Well, that's on purpose. Why? Because I want to have fast results. So if I run my test again, then immediately, well, depends on how fast my IDE is, immediately I get the result. Now it's green. Why? Because it just connects against the already running environment. So I don't have to restart and wait for the, like 5 seconds of startup time each and every time. Why? Because I'm impatient. And that's the point for testing with efficiency and joy. That's more fun rather than waiting. And, modern technology, like, modern Jakarta runtimes are really, really fast. That's good. But even 5 seconds, if you have to wait for a startup time each and every time, it just takes too long. So I really enjoy environments that just keep running the whole time during my local environment session, development session, and where I can just refire my tests. And now if you say, well, that's nice, but if I actually change some production code, I would need to redeploy it. Well, in this case, you can actually make use of these features like Quarkus and some other Jakarta runtimes have, is that you have some development mode, which is actually the case for me. So this runs now in a development mode, my Quarkus application, and I can actually make some changes. So let's try this out. I can say there's some builder for my root page here. So at first I have some, like hypermedia type links of this root page to says, well, here if you want the types, and here is how to order some coffee. And if I now enhance this for some, I don't know, just some hello response, hello JakartaOne, then what it does, it very quickly just recompose and restarts that application. And usually within a second or less, it just tells me, hello, JakartaOne, or, like, hello, Jakarta. And I can just very quickly make that change here, the live coding change. So I keep my application running, and then I immediately see the change being reflected. And of course, I can re-trigger my system test. So while I'm in this mode, and this is really the joy part of testing here, I can either change my production code or my system test code, and it already verifies my application, not only with a unit test, not only with code level tests, but already from a system test like scenario. So I really have confidence that later on everything will work as expected, and I have a proper verification. So this is really important, I would say, to just understand that I would like to separate these life cycle from the test environment to the test scenario. So my test should really just fire up against the environment that is already running. And later on, I also see like how I can make some some more enhanced changes for that. So that's this is really helpful. And as I saw, I always have fast feedback. I don't really have to wait here, because my application just whatever change I make, I can quickly either redeploy super fast or retest, and I always get very fast feedback within a second or two. That's really, really a nice way to do that. All right, so what I also would like to show you is, and then I can stop this local environment, is to do the system test against a Kubernetes cluster. So I have some Kubernetes cluster here via a cloud provisioning. So I have the IBM Cloud Managed Kubernetes Service with a Kubernetes cluster. Why? Well, because sometimes, now I will stop my local environment here, sometimes I have to test against some environment where I have not all of the things locally. I have, there are some ways to get that up and running as well, but sometimes it's just the case that I would like to test in an environment that is just, like closer to production with some login or authentication service being provided and so on and so forth. And by doing so, I can actually make use of these containers and of my proper test, like separations that I can quite quickly fire up against the different environment as well. So what I have my Kubernetes cluster that is empty here. And what I would like to do, just real quick, I want to deploy some system test environment to my Kubernetes cluster. So what I'm going to create is, well, actually very similar. I'm going to create a Kubernetes service and deployment for each, the coffee shop and the barista. In my case, actually also Wiremock for the system test and a database. So once that is the case, I have some pods running and some services. So if you're familiar with some Kubernetes environment, this might probably look familiar to you. And once that is up and running, I can actually see, well, I would like to talk to my now live or, at least system test application here. So if I ask for my IP address and say, well, please give me the health check, now this is actually running in this public cloud environment. And now I have my coffee shop in Kubernetes. So I will point, of course, you to all of these resources, how to try this out yourself. But the point that I want to make is not actually deploying to Kubernetes, but that I can reuse my system test now against a different environment. So I can say, well, actually, please point the system test not to this local environment, but actually to something else. And because I separated my life cycles here, I can actually say, well, use this barista system or the coffee order system and not use localhost, but just something else. So I can go to my system test environment and say now on the command line, because it's easier to reconfigure, if I say verify, Maven verify, this verify starts my Surefire tests, and I can say, please point these environment variables to the IP address of my cluster. And what it's going to do, it is actually going to create some coffee orders in my Kubernetes cluster in the system test environment. So I run the same test that I just had before, and it now uses a different environment to test against. So that's a nice story. I can reuse the test that I just wrote by having this separation, by having this abstraction in place. And now if I ask for the curl orders now it's actually being filled with my system test orders. So we saw that it's actually using this production cluster or system test cluster here with this environment. So that's really helpful to be able to reuse, these type of tests. So that's, I would say, a pretty cool approach to test with, again, efficiency and joy. And also, just to show you this whole approach with now a little bit different test scope. So now we had just the system test against either local development environment or against the Kubernetes cluster. And I showed you how to use, these development modes to get really fast feedback and, ideally quick turnaround times so that we don't have to wait because we're impatient. But now on a more code level, this is, well, a little bit of a similar story, but yet different. So now I'm going to show you some tests that you're probably a little bit more familiar with. So these tests actually do reside now in my project, in my coffee shop project. And I have something like, well, a test that, for example, would like to, test my coffee shop, for example. So I have a class that is here, a CDI class, and then I can see whether my class is doing all that stuff correctly. So that is the question. Now, does it make sense to write, a unit test like this? So I probably have seen stuff. I use typically tests without any other test runner or, any test extension. But I say, new. So I can invoke classes that are usually enterprise beans on a test. It doesn't matter, right? It just ignores these annotations. And then I can set, some dependencies via reflection or directly and use Mockito and things like that. But if you look at the test, is this really a good idea? Well, not necessarily. Why? Because, well, it depends what my class here does. If it doesn't have a lot of proper logic or, if it has not the correct cohesion to be tested in this way, if it just is more like delegation, then it probably doesn't really make sense to write a unit test for this. What I would like to have instead is what I call sometimes component tests or use case tests, which are code level tests that test the correct execution of my code path, but only locally as a code level test, but with multiple dependencies or multiple classes involved. So not only the coffee shop, but for example, the coffee shop plus this order processor and all of the classes that are part of this execution of my use case, like creating a coffee order. So for that, what I have actually, and if you think about it, I could use some fancy test framework to set up all of these things, or for example, to run my Quarkus now in an embedded mode. But then again, I have this lifecycle, I would say, issue that I have to wait for the application each and every time, even if it's just a bunch of seconds, but it's just slower than running everything just in plain JUnit, which is much faster. So what I do instead, I say I want everything on a code level as well, but I use, some abstraction and code quality techniques to just make it a little bit more worthwhile, to make it more efficient or especially more maintainable in the long run. So what I do, and that's some approach here, in my main scope, production scope, I have a coffee shop class and then another class. And now I do a TD, a test double, as in the test code that I use within a use case test, that sets up already some, test related wiring, like some mocks and, verification and all of that. So what I have my use case test that has a coffee shop test tool, which extends, I know this looks a little bit weird, it extends the production class. This resides in the test scope. And it says, well, actually, you want some mocking and all of this wiring logic, please do it in this component. So you only have to do it once with all of these, programmatic calls. But then the upside is that you only have to do it once and that you can reuse this test tuple here. And it also, can use a different wiring up to set the dependencies. And now this is my use case test, which looks super clean because it only has, like new order, create the order. And then this is a test specific method that I added on the test tuple to verify, create order, whatever that means. So I can do the lower level verification logic here that everything still, is very readable and yet runs fast because it's just a plain unit test. So I can run, these classes here, and once my IDE wakes up, this runs really, really fast. And plain JUnit, you can run hundreds of tests in no time. So this is just an approach to make these use case or component tests a little bit more, worthwhile, a little bit more efficient. So with that being said, I would like to just, cover some key takeaways from this. And probably one of the most important thing is that test code quality matters a lot. So it's not forbidden to include some test code quality in your test scope. It's actually a good idea. And most importantly, abstraction and separations of concerns, to use delegation and all of these things that we do all the time in production code, but also in our test code or test projects. That's a good idea. So create reusable test components and especially care about this fast feedback and turnaround cycles. And we get this by separating the life cycles. So I'm really quite stringent of just using easy lower level test technology, just like plain JUnit that runs super fast. And I rather set up my environment locally once, my system test environment, to say, Docker run 3 times. For me, literally, that's easier. If you want, you can run, test containers, for example, in just a main way. So not coupling it with the test class itself, but just running it standalone. Or you can run Docker Compose, or if you're fancy, you can run, local Kubernetes cluster, local OpenShift cluster, or whatever. But I would say it makes sense to be a little bit more pragmatic on that side and then separate these life cycles. And always, I claim the proper test code quality and these approaches are much more important than which test frameworks you use. So this is why I showed you just plain JUnit. If you would like to use whatever, Spark testing or something like that, if it's adds some benefit for you, sure, that's nice, then do it. I claim for the more complex your project becomes, actually the more important it is to cover this test code quality issue first. So that's more crucial from my experience, at least in real world projects. And with that, we can really test, with efficiency and also with joy. It's really fun to have a project that's well tested with maintainable tests, and then we have a much better quality. And I think that's a good thing. So then we're pretty much at the end of the talk. Thanks a lot for your attention. If you follow the first link, you can get access to all of these resources. You can try them out yourself. It also tells you how to set up, these Kubernetes environments and all of this. And you can check out my book on modern Java EE, or now it would be Jakarta EE. That covers a lot of these topics here as well, and some more links. Now, Ivar.
Yeah, that was excellent, and it's cool to hear somebody talking about joy and testing. That's and I even had to
I think it's a really cool
put
topic.
on my Quarkus t-shirt. So
awesome.
So there is one question here. Do you have any best practices or advices regarding integrating these tests into CI/CD, such as GitLab?
Yes, actually, the more you separate these life cycles, like I told you, the easier it is to integrate. Why? Because then you can very easily reconfigure it, like with these system variables that I did. So for this, what I had here with the Maven verify, this would be something that you would run in your CI/CD pipeline, Why? Because then it runs basically like headless. It connects to some other environment where in the first place you deploy to some environment and then you verify against this environment. So actually this is very easy once you do the separation of the test life cycles and not run everything, in one class. So that's actually very helpful in this regard.
Yeah, that's excellent. And I think our time is up. So thank you very much for joining us here, and look forward to seeing you again in a later occasion. And
yeah, likewise. And thanks a lot for your attention.
Yeah, thank you very much.
Bye-bye.
I guess we're just hanging around here until they pull us out, or we can just leave.
Yes, I don't know.
Or if you have anything else you can talk about.
We just like end here.
I think it's starting now.
Awesome.
Yeah.